So we like to take a few examples on separation of variables of solving a differential equation. So we have this differential equation and we want to find the general solution of the differential equation. And we try to use the method of separation of variables. Then what you need to do is you separate the variables, your x with the x and your y with the y. Then you integrate each side to get what the solution. So let's look at it. So this is our words differential words equation. So this is our differential equation. The aim is what to separate the variables. So let's check. We can cross multiply, cross multiply. So that I have what y squared plus 1 the y here to be equal to x, the what? The x. Yay! Good. So this is what we have been able to separate the variables we have. Why? Because you have all your y's with the y and all your x words with the x. So the next thing to do is what? To integrate what? Both sides. So what do? I find the integral of y squared plus 1 dy, then integral of what? X the what? X. This using the sum rule, it's equally equal to the integral of y squared dy plus the integral of what? Dy to be equal to what? Integral of what? X dx. So this is where our revision of integration is what? Very what? Important. So now let's look at it. So if I integrate this, what do I have? I have what? Plus 1. So what we do is you add plus 1 here, then you have what? 2 plus 1. So I have y cubed over 3 plus integral of the y here is going to be what? Y to be equal to integral of this is going to be what? X squared over what? 2 plus what? A constant. So this is what? My general word solution. So this becomes our general solution. If you take it slowly, let's take another simple example. Let's another example. Let's I'm saying it is 2. I want to find the general solution of what? Dy over dx to be equal to x over what? Y. So this is my what? Differential equation. What do I need to do? I need to separate what? The variables. And this looks so simple. So from here, what do I have? I have y dy to be equal to what? X dx. So good, we have been able to separate what? The variables here. So the next thing is what? Integrate both sides. So let's do the integration. I integrate y dy to be equal to what? The integral of x dx. If you integrate y, what do I have? I have y squared over 2 to be equal to x squared over 2 plus a constant word c. Plus a constant word c. So you realize that with this solution, I can find the antiderivative of each side. So finding the antiderivative of each side, let's multiply through by 2. If I multiply through by 2, what does it mean? It means that I have y squared. So let's say I multiply through by 2. If I multiply through by 2, what do I have? I have y squared to be equal to what? X squared plus 2c, because we are multiplying through by 2. But So here from you have y squared to be equal to x squared plus what? C. Because 2 times a constant, you still have your constants. So that if you see C, just C, it means you have a constant. If you multiply by any scalar, you are still getting what? A constant. So even if this was, let's say, C1, I mean C subscript 1, then I want to say my final answer here is going to be this. Because each side of equation by 2 to produce a certain constant, what? C. So that's it. The method of separation of variables. If you're asked to find a particular solution, then what it means is that the initial conditions will be given to you. So you could find the value of what? C, then you do the substitution to get what your particular what solution. Thank you so much for joining us. If you are new to the channel, don't forget to subscribe and share among your networks as well. Thank you and take care.